Here we're asked to solve this triangle. Notice, this is an oblique triangle, has no right angles. SOHCAHTOA won't work, but the law of sines will work. When it says solve the triangles, I've got to find all angles and all sides. So I'm given angle, angle, and a side. You know what? I can figure out what angle A is by saying, I know that the interior angles of the triangle sum up to 180 degrees. So if I have 180 degrees to play with, and I subtract 102.3 degrees from angle C, and then from that I subtract 28.7 degrees from angle B, I'm left with 49.0 degrees. So 49.0 degrees is something I can count on now. I think I've got that right, by the way. And now I can go after the unknowns. The unknowns are these two sides. So I know that sine A over A equals sine B over B equals sine C over C. Let's go after A. So I'm using sine of A, which is 49 degrees, over A is equal to, well, I've got this side and this side, so I'm going to say sine of B, 28.7 degrees, over 27.4 feet. I'm going to leave feet off, and we'll make sure we put the correct units on at the end, because I know that our answer is going to be in feet up here. So if I cross multiply, and this is the only time it's appropriate to cross multiply, when you have a fraction equal to a fraction, it's a proportion. So if I cross multiply here, I'll get A sine 28.7 degrees is equal to 27.4 sine 49 degrees. Notice I try to put the number sort of as the coefficient of sine so that I don't get confused. Sine 49.0, 27.4 doesn't make much sense to me. Now we're trying to solve for A. This is A times sine 28.7. So if we divide both sides by 28.7 degrees, the sine of, I'll have 27.4 sine of 49 degrees divided by sine of 28.7 degrees. Now, if you have a small calculator, it's not a super-powered CAS or something like that, you're going to have to put parentheses around the numerator divided by parentheses around the denominator. You have to do that. And then if you have a small calculator, again, you'll have parentheses around the argument of sine, so it'll look something like this. Now, if you do have a CAS or a CX from TI, I encourage you to use control division, because that will make a fraction bar and it makes your life a lot easier. Try that out if you have one of those high-speed calculators. Control division makes your life easier. And this allows us to find the distance of A, which is about 43.06. Let's report to the nearest hundredth feet. So this allows us to put this here as 43.06. Notice I'm always good about putting my units on. I always double check that before I hand anything in. Now that I've got this much information, my only unknown is C. And I could say C over sine 102.3 degrees is equal to, well, you know what? I calculated this and I calculated this, and I think they're right. But why don't we go back to the given information, because I know this is right. So I can say that B is 27.4 feet over the sine of 28.7 degrees. Again, when we have a fraction, cross multiply, a fraction equal to fraction, cross multiply. It's a proportion. So I get C sine 28.7 degrees is equal to 27.4 feet. I'm just going to keep that out for a moment, times sine of 102.3 degrees. Now, notice this is sine of an obtuse angle. I can do that. It's inverse sine of a ratio that I can't go and find an obtuse angle, but I can find the sine of an angle in quadrant 2. There's no restriction on sine, but sine of an angle, but the restrictions come on inverse sines. Just be careful of that. So C is equal to, this is C times sine 28.7. I'm going to divide both sides by sine 28.7 and get 27.4 sine of 102.3 degrees all over sine of 28.7 degrees. Notice, if you don't have one of those high-speed calculators, you're going to have to say, here's my numerator, in parentheses, divided by, here's my denominator. And when you do that, you're going to get, C is about 55.75 feet. Notice I put my units on there. So here I'll say 55.75 feet. And I have solved the triangle using the law of sines heavily. I've got my 3 sides and my 3 angles. Notice, biggest angle across from biggest side, smallest angle across from smallest side, and medium angle across from medium side. We have that side angle relationship. Let's apply the law of sines. A pole tilts toward the sun at an angle of 8 degrees from the vertical. So here's the sun over here, and the pole is vertical up, but then it tilts 8 degrees towards the sun. And so if the sun is over here, the shadow is coming this way. The shadow is 22 feet. So from here, from the base of the pole to the edge of the shadow is 22 feet. The angle of elevation from the tip of the shadow here to the top of the pole is 43 degrees. Remember we talked earlier about how the angle of elevation and the angle of depression involve the horizontal. So I'm very happy to see that I have a horizontal in there. How tall is the pole? You know what? A better question would be, how long is the pole? So we're asked for this distance here. That's what we're after. So because how tall, we'd have to make another right triangle and make a hypotenuse out there, which wouldn't be too bad because we could use right triangle trig. So notice what we've got. I called this angle over here A. The big vertex here is B, and this angle is C, forcing this to be small b, small c is 22, and A is what we're after. Well, we do know some things, right? We do know that if this angle is the vertical, it's 90, plus 8 is 98 degrees. So then this angle here has got to be, C is 180 minus 98 degrees minus 43 degrees. So we can plainly see that angle C has to be 39 degrees. So we've got this now too. And that allows us to use the law of sines. It's an oblique triangle. Law of sines also works for right triangles, by the way. So I can say, because I'm looking for A, I can say A over sine of A, which happens to be 43 degrees, is equal to, well, I do know that B here is 22 over sine of 39 degrees. So I'm expecting a distance larger than 22 because 22 is associated with 39. So 43 is bigger than 39. So I'm expecting A to be larger than 22. If I've done it right, that's what will happen. So when I cross multiply, I get A sine 39 is equal to 22 sine 43. Divide by sine 39, A is equal to 22 sine 43 over sine 39. And if you put parentheses here and parentheses there, or use that control division button on the high-speed TI calculators, you'll get about 23.84 feet. And that's what we were after, side A. Nice, we got it. And that's a little bit bigger than 22, so I'm happy about that.